So hello everyone. Today I'm taking the session for mathematics for EC engineers. The subject code is BMAT EC 301 and I'm starting with the first module, which is Fourier Series and Practical Harmonic Analysis. So Fourier Series is the first chapter of this module. So we'll study the definition of Fourier series. The definition is: a Fourier series is a representation of the periodic function as a series of sum of sine and cosine functions. So basically a Fourier series is as the definition says, it's a representation of a periodic function. That periodic function is given as f of x, and it consists of some sine and cosine functions along with some coefficients like a0, an and bn. These coefficients are known as Fourier coefficients. So uh, in all of these Fourier coefficients along with the trigonometric functions will together become a Fourier series. That is a0 by 2 plus summation from n raised to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. So this is a Fourier series. So now let's talk about even and odd functions in various intervals. So in this module there are basically three main intervals which you need to study. They are the intervals from minus pi to pi, 0 to 2 pi and minus L to L. So we'll start from minus pi to pi. So let's see what are even and odd functions in minus pi to pi. So a function is said to be even if f of minus x is equal to f of x. So basically in the question they will be giving the f of x equal to they'll giving the function of f of x. The first step what we need to do is we have to replace x by minus x. So after replacing it, and we need to simplify that f of x term, and if that term matches with the given term, that is f of x, then we say that the function is even. In other case, a function is said to be odd if f of x is equal to minus f of x. F of minus x is equal to minus f of x. The same thing, if we substitute replace x by minus x, and by simplifying, if we get minus of f of x, then we say that this function is said to be odd. So these are all about even and odd functions. So now let's solve some examples. There are below. The first example is f of x equal to x. So now let's replace x by minus x. So what happens? This becomes minus x. So we can see that this is equal to minus of f of x, right? So by the definition we know that if f of minus x is equal to minus f of x, then this is an odd function. Let's see the second example. F of x equal to x square. Same thing. F of minus x equal to minus x the whole square. This becomes x square, which is equal to f of x. The given f of x, and we have simplified this f of x, f of minus x, which is equal to f of x. So we can say that this is an even function. The same thing, third example, let's take a trigonometric function sin x. F of minus x is equal to sine of minus x. We know that sine of minus x is minus sine x, which is equal to minus f of x. So we can say that by the definition it's an odd function. So now let's try even for cos x. F of minus x, that is cos of minus x. We know that cos of minus x is cos x, which is equal to f of x. So by this we can say that this is an even function. So these are the few examples to make you clear about the concept even and odd functions. So we are going to apply this in many problems in the future. So now let's see some other topics. Okay, so now let's see what is Bernoulli's rule. So we are going to apply this rule in many problems, like nearly in all the problems we are going to apply this rule in 90% of the problems. So it is basically all of you have heard about integration by parts, right? This is basically an easy process. So in order to avoid integration by parts, we use this Bernoulli's rule. So there basically, if they're the product of two functions, that is u and v, inside an integral. So the rule goes like this: first function into the integration of second function minus the differentiation of first function into the integration of this integrated function, that is double integration, plus differentiation of this differentiated function, that is u double dash, into the triple integration, means integration of this function. So in simplifying way, we can write it as u v1 minus u dash v2 plus u double dash v3, and this goes on. And the order of signs is also, it's plus minus plus, see, plus minus plus, it goes on, where u dash and u double dash are the derivatives, and v1 v2 v3 are the integrals, like the integrals of the integrated functions of the previous. Like v1 is the integration of v2 is the integration of v1, v3 is the integration of v2, and this goes on. So this is all about Bernoulli's rule. So now the concept starts. Now we'll get you know about the different intervals. Now the first interval is Fourier expansion in interval minus pi to pi. So basically there are three cases. The first case is f of x is neither even nor odd, means it is not even an even function nor an odd function. In that case, there are three formulas for Fourier coefficients, that is a0, an and bn. There are three different set of formulas. So now let's see that. First is for a0. A0 formula is 1 by pi integration from minus pi to pi f of x dx. An equal to 1 by pi integration from minus pi to pi f of x cos nx dx. Bn 1 by pi minus pi to pi f of x sin nx dx. So these are the three set of formulas in case if the function is neither even nor odd. Like for that we need to simplify it. Okay, so after substituting the values for these Fourier coefficients, the Fourier series will be like this, that is f of x equal to a0 by 2 plus summation n tends to 1 to infinity an cos nx plus summation n tends to 1 to infinity bn sin nx. So this is the Fourier series. By substituting the Fourier coefficients in the respective places, we get this series along with the trigonometric functions. So now let's see the second case, that is if f of x is an even function. Again, in case of even function, there are three sets of formulas for a0, an and bn. If f of x is an even function, we need to remember one thing, that bn function, right, the one Fourier coefficient bn, that is equal to 0 if the function is an even function. There are only two formulas, that is for a0 and for an. Let's write it. a0 equal to 2 by pi integration from 0 to pi, this time it's 0 to pi, when in either neither even or not, it was from minus pi to pi. Okay, f of x dx. An equal to 2 by pi 0 to pi f of x cos nx dx. So these are the three Fourier coefficient values. So let's write the Fourier series in this case. Let's see what it becomes. a0 by 2 plus summation n tends to 1 to infinity an cos nx. So we can neglect the bn sin nx term, since we know that bn equal to 0, there is no use of writing that. It's basically plus 0. So we can neglect that part, and this will be your final Fourier series. So in third case, if f of x is an odd function, the same thing here, a naught is equal to 0 and also an is equal to 0. The two Fourier coefficients are equal to 0. The two Fourier coefficients are equal to 0. There is only one formula, that is for bn. That is from 2 by pi integral from 0 to pi f of x sin nx dx. So the Fourier series also consists of only bn term, that is summation from n tends to 1 to infinity bn sin nx. That's it. This is the required Fourier series. So now let's see some notes. The first note is, if f of x is defined as from minus a to a, that is the interval from minus a to a generally, then f of a, we can write f of a as f of minus a plus f of a by 2. Now if I say this, you won't get to know. I'll explain this during the problems in brief, that how this function will come. So now let's go to the second note. So the second note is, if f of x is a discontinuous function, that is, if f of x has two set of values, that is phi of x and xi of x generally. In the question they will be giving two sets of values, and the first set f xi of x, it tends from minus pi to 0. So the total interval is from minus pi to pi, right? We can split those two, like from minus pi to 0 and from 0 to pi. So there are two f of x values, and we represent them as phi of x and xi of x. In this case, the f of x in even and odd functions, there are some set of rules that it needs to be followed. So let's see that. If f of x is an even function, then we write it as phi of minus x is equal to xi of x. Phi of minus x is equal to xi of x. So we need to, whatever phi of x is given, you have to replace the value of x by minus x, and if we, after replacing and after simplifying, if we get xi of x, right, then we say that f of x is an even function. F of x is an even function. In same case, if we say that f of x is an odd function, if xi of minus x is equal to phi of minus x is equal to minus xi of x. If phi of minus x is equal to the value of minus xi of x. So this is the case where when in a question they will be giving two set of values for f of x. One value is from minus pi to 0 and another value is from 0 to pi. We need to split the limits. So these are all about the concepts and all the introduction related to the interval minus pi to pi. So now let's solve few problems. There are basically two problems, two basic problems and two very important problems which you people need to practice, and similar type of questions might be asked for the exams. So let's solve those problems. Yeah, so the first problem, problem statement: find the Fourier series expansion of function which is given as f of x is equal to mod x in the interval minus pi to pi. So now let's solve this problem. The given function is f of x equal to mod x. So the first step which I have told is we need to replace the value of x by minus x. So the function becomes minus mod x. We know that whatever is inside the mod term, either it may be positive or negative term, it turns into a positive term. So minus of mod x is x. So this is equal to f of x. So we say that this is an even function. So we know that in even function we have studied the Fourier coefficients, the formula for Fourier coefficients, we'll write it. In even function we know that Bn equal to 0. So now let's without wasting time we'll find out the other Fourier coefficient, that is first is a0. The formula is 2 by pi 0 to pi f of x dx. We'll substitute the value of f of x, that is 2 by pi 0 to pi x dx. So now let's integrate this, that is 2 by pi, the integration of x is x square by 2. Let's write the limits. Now let's split the limits, that is pi square by 2, upper limit minus lower limit, right? So minus 0 square by 2 is 0. So a0 is 2 by pi square by 2. So 2 gets cancelled, one pi term will get cancelled, so final value of a0 is pi. Yeah, so now let's find an. Substitute the value of f of x cos nx dx, that is an equal to 2 by pi into the sine n pi term gets cancelled, so minus 1 to the power n. The value of cos n pi is minus 1 to the power n by n square minus 1 by n square. So here we can see that 1 by n square term is repeated, it's common, so we can take that term outside, that is 2 by pi n square. So whatever the term is remaining, write it minus 1. So this is basically the value of an. So we found out the Fourier coefficients. We know that Bn equal to 0, we found out a0, an. Now we'll finally write the Fourier series, that is f of x is equal to, what's the value of a0 that we get? That we got pi. So a0 by 2, so pi by 2 plus summation n tends to 1 to infinity. The value of an is 2 by pi n square 1 to the power n minus 1 cos nx. So this is the required Fourier series. So Bn term is 0, so we can neglect that. So this is the Fourier series for this problem. We'll get to the next problem. Yeah, so this is the second question. Obtain the Fourier series in interval minus pi to pi when f of x is a discontinuous function in this case. So see, there are two values, right? One is for phi of x, one is for xi of x, and see the limits that I've told you before. So now let's simplify this. Phi of x is this function, so now replace by minus x, so this becomes 1 minus 2x by pi. If you replace x by minus x, it becomes 2 into minus x, that is equal to minus 2x by pi. So we can see that this and this are same, right? So this is equal to xi of x. So when phi of minus x is equal to xi of x, we say that the function is even. So now it's an even function, so we know that Fourier coefficient Bn is equal to 0, and we need to find a0 and an. Let's find them. Let's find a0. This is the formula for a0. 2 by pi 0 to pi f of x dx. So the interval is from 0 to pi, and in the question the interval from 0 to pi, right, the function is 1 minus 2x by pi. So we need to write this function, this value for f of x. So because the interval tends from 0 to pi, let's substitute f of x, 1 minus 2x by pi dx, 2 by pi into the integration of 1 dx is x minus 2x square by 2 pi. From the interval 0 to pi, here cancel 2, so a naught equal to 2 by pi into x minus x square by pi. Substitute the limits. Pi minus pi square by pi minus 0, everything becomes 0, minus 0. Pi into pi is pi square, cross multiply. So this becomes 0, this whole term becomes 0, so a naught is equal to 0. So we found out a naught. Similarly we'll find an. So we'll find an, this is the formula for an. We'll substitute the f of x value. Same thing, from 0 to pi, so we need to consider 1 minus 2x by pi cos nx dx. So now there are two functions, so we can use the Bernoulli's rule. So I said right, Bernoulli's rule is applied nearly in all the problems. So now we'll apply it. First function into the integration of second function, that is sin nx by n, minus the differentiation of first function, that is 0 minus 2 by pi. Integration of 2x is 2, 0 is 1, and 2 by 2x is 2x by pi. Differentiation is 2 by pi. We wrote it. And integration of this function is minus cos nx by n square from 0 to pi. So now we need to substitute the limits. That is 1 minus 2 pi by pi sin n pi by n. So minus into minus, 0 minus 2 pi is minus 2 pi, so minus into minus is plus 2 by pi minus cos n pi by n square minus 1 minus 2 into 0, so this becomes 0, 0 sin 0 by n minus 2 by pi. The same thing, minus into minus is plus, and plus into minus is again minus, so I have written minus 2 by pi cos 0 by n square. So here sin 0 is 0, we know that sin 0 is 0, this term gets cancelled, and sin n pi is also 0, so this term also gets cancelled. These two terms gets wiped out. Here again plus into minus is minus, so we'll write minus 2 by pi. The value of cos n pi is minus 1 to the power n by n square plus 2 by pi. Here how it become plus, because here there is minus right outside. Minus into minus again becomes plus, so plus 2 by pi. The value of cos 0 is 1 by n square. So now here 2 by pi is common, take it outside, so it becomes 2 into 2 is 4, and pi square. Also we can take n square outside, no, right? We can take n square also out, right? See, there are repeated, so we'll take even n square outside. So it becomes 4 by pi square n square. What are the terms remaining? Minus of minus 1 to the power n plus 1. 4 by pi square n square minus 1 to the power n plus 1 plus 1. So this is an. So how we got this n plus 1? So there is a trigonometric, so there is an identity, not a trigonometry but an identical identity. That is, here there is a minus 1, right? So we can even write it as minus 1 to the power 1. There are same base, right? Minus 1 and minus 1 with different powers. So if there are same base with different powers, we can equate the base, like we can write a single base with the addition of the powers, that is n plus 1. So that's what we have done here. So we got minus 1 to the power n plus 1 plus 1. This is the value of an. Now we'll write the Fourier series. F of x equal to, we know that a naught is 0, so we'll neglect that. An 4 by pi square n square minus 1 to the power n plus 1 plus 1 cos nx. So this is the required Fourier series. So we have solved two problems. One is a simple problem, continuous function with only a single f of x value, and the second is a discontinuous function with two f of x values, phi of x and xi of x. And we have solved these two problems. So we'll continue with some more problems and more advanced problems, and it's easy actually. So you need to understand it. That's it. So if you show the interest towards this will be a cakewalk and very easy, and you can score very good in exams. So I am also basically a student, and I am also studying engineering same way as you are studying. So this is my first video, and my duty, and I think that my duty, I understand math, this subject very well, so I think that I need to give this learning, or whatever I understand, I need to spread this to in a large range. So I'm pretty bad at communication, and I'll promise you that I'll improve it. So we'll be seeing many more sums in the future. Thank you.